Welcome to week 13 revision. This time we are looking at units of data and binary numbers. This is paper 1, 1.2b. So, sheet 13, please find it and have it with you, ready to complete and fill in. Okay, so units of data. Remember, everything on a computer is stored as binary. Computers are made up of electronic circuits that have switches that go on or off, binary. 1 represents on and 0 is represented off. 1, 0. 2 states. All data, regardless of what it is stored in binary. Patterns of binary. Text, images, sound, video. It's just patterns of it. Okay? So remember, when we are storing this binary, you have either a single switch, can be either 0 or 1. If you have 2 switches, you can have 0, 0, 0, 1, 1, 0, 1, 1. If you have 3 switches, you have 8 combinations. The more switches you have, the more different combinations you have. So 1, 2, 3, then it goes to 16, 32, 64, 128, and 256. Binary numbers. The more bits you have, the more switches you have, the more possible combinations you can have. So how is it stored then? A single 1 or 0 is called a bit. A single 1 or 0, a bit. 4 bits is called a nibble. 8 bits is a byte. 8 ones or zeros. From then on we've got kilobytes, megabytes, gigabytes, terabytes, and petabytes. There we go. Bit is represented by a B. Nibble, there is no shortened abbreviation for nibble, but it's 4 bits. A byte, capital B, 8 bits. A kilobyte, KB, 1000 bytes. A megabyte, MB, is 1000 kilobytes of the previous. Gigabyte, GB, 1000 megabytes, the previous one. Terabyte, TB, 1000 gigabytes, the previous one. And petabytes, PB, 1000 terabytes. It's always 1000 of the previous unit. Apart from obviously lower down where it's a single 1 or 0, 4 or 8. A byte is big enough to store a single character. Kilobytes will store small images and things. Then we've got music files which are short enough to store. Gigabytes are big enough for films and games and things, and terabytes is like massive amounts of storage. So on your sheet please, can you fill this in? Put the units in order on the sheet. Bit, nibble, byte, kilobyte, megabyte, gigabyte, etc. What's the abbreviation and description? What is it equivalent to? Complete that now. Okay, check your sheet with Purple Pen. You should have something like this. Bit, B, single 1 or 0, nibble, there's no abbreviation for nibble, 4 bits. A byte, capital B, is 8 bits. Kilobyte, KB, 1000 bytes. Megabyte, MB, 1000 kilobytes of the previous one. Gigabyte, MB, terabyte, TB, 1000 of the previous. Check Purple Pen, tick or correct. Okay, now we know the units of data, we've revised that. How do you convert between the different units of data? If you wanted to convert, so we know 1 nibble is 4 bits, we know 1 byte is 8 bits, and we know 1 kilobyte is 1000 bytes. And 1 megabyte is 1000 bytes, etc. 1000, 1000, 1000. So how would you convert 100 bytes into bits? We are going from bytes here into bits. Well, if there's 8 bits in 1 byte, you would simply multiply it by 8. 100 times 8 gives you 800. How about from gigabytes into megabytes? Gigabytes to megabytes, there's 1000 megabytes in a gigabyte, so you would multiply by 1000, 15,000. And terabytes to gigabytes, again, there's 1000 gigabytes in a terabyte, so you would multiply by 1000. 4 times 1000 gives you 4000. Now it gets a little more complicated if you want to go several steps in one direction. If you want to go, for example, from gigabyte to kilobyte, you have to multiply by 1,000 and then multiply by 1,000 again. And the more steps you go down, the more times you'd have to multiply. What about the other way? If you're going upwards from byte to kilobyte, for example, you would divide by 1,000. You have to divide by 1,000, and again, if you wanted to go from byte to megabyte, divide by 1,000 and then divide by 1,000 again. Use this little chart here to help you and support you with converting the numbers. On your sheet, have a look at the example questions. Use the chart here to help you if you need support. I want you to see if you can fill these in and try to show some working as well. What have you multiplied or divided by to get the answer? Convert 20 kilobytes into bytes. What have you done to it? Workings, answer, off you go. Okay, purple pen's ready to tick or correct. So 20 kilobytes into bytes. Kilobytes to bytes, we need to multiply by 1,000. Kilobytes to bytes, multiply by 1,000. 20,000 bytes. 1.5 gigabytes into kilobytes. Gigabytes to kilobytes, we'd have to multiply by 1,000 and then multiply by 1,000 again because we are doing 2 stages down, 2 units of data. So we come out with 1,500,000 kilobytes. 0.5 terabytes into megabytes. We are timesing 0.5 by 1,000 and then by 1,000 again. So we get 500,000 megabytes. This time we're going from bytes to kilobytes. Bytes to kilobytes. So we are dividing by 1,000. 1,000 divided by 1,000 gives us 1 kilobyte. Make sure you put the units at the end. 500 megabytes to gigabytes. Megabytes to gigabytes is divided by 1,000. 0.5. And finally, kilobytes to gigabytes, well, that is 2 stages. So we're going from kilobytes to megabytes, megabytes to gigabytes, divide by 1,000, and then divide by 1,000 again. 0.1 gigabytes. Taking your answers, adding corrections or purple pen to show your workings before moving on. Okay, so we know about binary and units of data. We know how to convert. What is binary and why use it? So we know all data is stored on the computer as binaries because computers are made up of switches that can go on or off. On being represented by 1 and 0 is off. Binary. So computers are electronic circuits. This is the key bit. Millions of switches. On, off. On is 1, 0 is off. And our columns along the top we'll talk about in a second. So the more switches and bits we have, the more combinations we can have. With one switch we have 2 combinations, 2 switches we have 4, 3 switches we have 8, 2, 4, 8, 16, 32, 64, 128, 256. Remember the combinations double every time you add a new switch. So 8 switches here, on, off, 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 on, would be represented by 10001010. And there are 256 combinations with 8 bits or 8 different switches, going from 000000 to 11111111. What are the advantages? What are the good things about using binary? Binary is high tolerance. That means it makes less mistakes to tell the difference between 1 and 0 than it would be if you had a decimal number, for example. There's less mistakes, high tolerance. It's much easier or clearer to record and use. It's much more easy to say 101001 than a decimal number. And computers generally only have 2 states, either on, off, north, south. They represent things as. So high tolerance, clearer, easy to use, and computers only generally have 2 states. Okay, on your sheet, what were the columns in binary, starting from the right hand side? Why use binary and what were the advantages? Off you go. Okay, purple pens, ready to tick, add correct. Your columns along the top, remember, 1, 2, 4, 8, 16, 32, 64, 128. You just need to know those, the columns in binary. Why is binary used? Because computers are made up of electronic circuits that have millions of switches. Those switches can be on or off. On is 1, 0 is off. Simple. Advantage using binary, it's high tolerance, less mistakes, clearer and easier to record and use, and computers generally only have 2 states they can use, on, off, north, south, etc. Okay, so we know all data is stored in the computer as binary, patterns of binary numbers. Final thing to revise today is the basics. How do you convert from binary to denary and denary to binary? Well, remember, humans use denary numbers, decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have the columns like this. However, computers don't use those, they use the binary columns, 1, 2, 4, 8, 16, 32, 64, 128, and obviously it goes higher, 256, 512, etc. They double each time. If you want to make a number, for example 183, you would just have to turn on the columns to make that number, and there is only one possible way of making it. 128 plus 32 plus 16 plus 4 plus 2 plus 1 would give you 183. So for example, if we have the binary number this, 11010, we want to convert that into denary human numbers. All we've got to do is draw out the columns along the top, 1, 2, 4, 8, 16, and you are interested in the columns with 1s in it. We ignore the columns with 0s, so 16 plus 8 plus 2 gives us 26. Same thing goes here. If we wanted to do the other way around and work at the number 79, all we have to do is work out which columns need to be turned on to make the number 79. Slightly harder, so you would start at the highest end. Here, 128 is too big for 79, so we put a 0. 64 does fit into 79, so 79 minus 64 gives us 15, and from there we can then work out the other columns. To double check your answers, if you added up 64 plus 8 plus 4 plus 2 plus 1, that should give you the number 79. Okay, your turn to practice. Okay, I've given you one with the columns on to start with. At the top, add up the ones with 1s in it. What is the denary number from binary to denary? On the other two examples, you need to write out the binary columns, 1, 2, 4, 8, 16. Always write them out to show your workings. And denary to binary, again, turn on the columns to make the number 86, 105, and 190. Do that now. Okay, hopefully you've had the time. Checking your answers, let's see if you've got this correct. Always make sure you've shown your workings for this. So, we've got, first one is 91. Why? Because it's 64 plus 16 plus 8 plus 2 plus 1. Our second one, write out your binary columns, 1, 2, 4, 8, 16, 32, 64, 128. And we should have 128 plus 16 plus 8 plus 4 gives you 156. And our third one, write out the columns 1, 2, 4, 8, 16, 32, 64, 128. We've got 128 plus 64 plus 4 plus 2 plus 1 gives you 199. From binary to denary. How about the other way? 86. How do we make the number 86? Well, 128 is too big for 86, so that's a 0. 64 does fit in, so we do 64. That leaves us with 22 left. 32 is too big, so we put a 0. 16, 22 minus 16 gives us 6, and from there I simply know that it's 4 and 2. So 0, 1, 0, 1, 0, 1, 1, 0 equals 86. Next one, write out the columns. 1, 2, 4, 8, 16, 32, 64, 128. To make 105, well, 128 is too big, so that's 0. 64 does fit into it, so 105 minus 64 leaves us with 41. 32 fits into 41, so 41 minus 32 gives us 9, and to make 9 it's just 8 and 1. So there's our binary number, 0, 1, 1, 0, 1, 0, 0, 1. And finally, 190. Write out the columns. This time it is big enough. So 190 fits 128 into it, so 128 so 190 minus 28 gives us 62. 64 is too big, so that's 0. 32 does fit into it, so that leaves us with 30. 30 minus 16 gives us 14. 14 minus minus 8 gives us 6, and then it's just 4 and 2. So 128, 32, 16, 8, 4 and 2 gives you 190. Okay, if you finished the sheet, correct and corrected, go on to LearnCoding Quiz 13, revision quiz 13, to test your knowledge. As always, check each question. Try again if you don't get it right. You are aiming for 100%. See you in lesson.